In this example, we're going to add or subtract the following polynomials as indicated. Recall when we combine the polynomials, we use the property like we add or subtract like terms. For part A, we have the expressions x times y minus 5y plus x to the third times y plus the quantity x 8x minus xy to the third minus x times y. First of all, just take away the grouping symbol and then look for like terms. Since this is a sum, so we just take away the grouping symbol without rewriting any sign. And after that, we look at like terms to combine the coefficients. For the first term, like x times y, we have another like term, which is negative x times y, the last term. So these two can be canceled out because one is positive, the other one is negative. For the term negative 5y, we do not have any other term that's considered as a like term. So we keep it as negative 5y. The next one is x to the third times y. We do not have another like term as well. So that means plus x to the third times y, similar to the 8x and negative 8 times y to the third. As you see the result here, they are not like terms. That means we are done adding or subtracting or simplifying this expression. In part B, we would do the subtraction of these two expressions. First of all, take away the grouping symbol. And the second quantity, we apply the negative sign or distribute negative sign to all terms. Going to be negative 2 plus 4 times x to the third. And next we look for like terms. Negative 7x to the third is the like term of the 4x to the third. So these two, we just combine the coefficient. Negative 7 plus 4 becomes negative 3 with the common variable term x to the third. And the next part would be the number 10 and the number negative 2 combined to be or simplified to be positive 8. And then the last term, which is the negative 9 times x to the fourth, only one single term left, so no like term. We just carry it over. So negative 9 times x to the fourth. So the simplified expression for part B would be negative 3 times x to the third plus 8 minus 9x to the fourth. For this example, we are going to multiply the following polynomials. In part A, we have the product of the expression negative 7x to the third plus 10 minus 9x to the fourth and the quantity 2 minus 4 times x to the third. We just treat them using the distributive property. So negative 7x to the third distribute to all terms in the second quantity or the second expression and do the same for the rest of them. Then we can get the first product, which is negative 7 x to the third times 2 becomes negative 14 x to the third. And then negative 7 times negative 4 becomes positive 28 x to the third times x to the third becomes x to the sixth. The next one going to be 10 times 2 becomes positive 20. 10 and negative 4x to the third is negative 40 x to the third. And then the last product would be negative 9 x to the fourth times 2 or negative 18 x to the fourth. And the last one would be negative 9 x to the fourth times negative 4 x to the third. It becomes positive 36 times x to the 7. From these 6 terms, we are going to look for like terms to combine. For the power 3 of the x, negative 14 x to the third, we have another term that has the same variable factor, which is x to the third as well. So these two combine to be negative 54 x to the third. And then for the power 6 term, we have only one term that contains the variable factor x to the 6. So just carry it over, 28x to the 6. And now for the number terms would be the same, plus 20. For x to the 4th, also one single term, so negative 18x to the 4th, carried down, also the power 7 term. So now rewrite it in a nice order from the higher power to the lower power. So gonna be 36 x to the 7 plus 28 x to the 6 minus 18 x to the 4th minus 54 x to the 3rd, and then plus 20 as the simplified polynomial expression in descending order form. For the second example, we are going to do the perfect square of the quantity 2x minus y to the 3rd power. Recall the power 2 means the quantity multiplies itself twice. So the quantity 2x minus y to the 3rd multiplied by 2x minus y to the 3rd. And then we use the distributive property or use the Foy technique. The first times first, outer times outer, inner times inner, last times last. For the first times first, 2x times 2x becomes 4x to the 2nd. The outer times outer, 2x times negative y to the 3rd is negative 2 times x times y to the 3rd, similar to the inner term. So negative y to the 3rd times 2x is negative 2 times x times y to the 3rd. I write in the same order as other terms. So x first and then y later. And then the last times last, negative y to the 3rd times negative y to the 3rd. Two negative signs multiplied becomes positive inside. Y to the 3rd times y to the 3rd becomes y to the 6th because we add the power together. And then for this expression, we can see that two terms, they are like terms. So we can combine the coefficient and it becomes negative 4x squared, which is the same as before because there's no like term to this. The two like terms now combine to be negative 4 times x times y to the 3rd, and then plus the last term, which is y to the 6th power. So we are done simplifying this perfect square term.